In this video, I'm going to just look at one example from the homework on increasing, decreasing, and constant. This is number 4, looking at where is a function increasing, where is a function decreasing, and where is it constant. But this problem also includes questions about domain and range and intercept, so I thought it was just a good one to kind of look at a lot of the topics that we've been talking about, okay? All right, so they gave us a graph, and the first question just asked for the domain of the function. So we don't have the equation, we're just looking at the picture. And remember how the function is being given to us as just this graph right here, but see it as, infinitely many ordered pairs. When you're doing domain, you should be thinking about what are the possible x's, what are the x's of those ordered pairs. Think about the leftmost, the rightmost, and whether there's any gaps as you go from left to right. So the domain actually turns out to be from negative to positive infinity when you look at that. And remember, you can also do these, consider domain by thinking about projecting the points onto the x-axis. So this point, for instance, would have an x-coordinate there. This point would have an x-coordinate there. This one would have an x-coordinate there. This one would have an x-coordinate there. You just smash it, and then you see what would be covered up on the x-axis, and that's another way to confirm that the domain is all reals, okay? Now for range, you can do a similar thing, but what you would do for range is you'd be thinking about lowest and highest, because you're thinking about the y-coordinates. So the lowest point is right here, and then this arrow tells you that it keeps on going. So this right here isn't included in the range. I mean, you don't stop at that spot right there, because this arrow tells you there's ordered pairs way up here. So if you projected these points onto the y-axis, yes, all of those would go right there. What is that, 18, 19, 20, 21, but then wouldn't that point right there go to 24, and this would be even higher, and this would be even higher, and then these points would project over, and you would have all of that covered up, okay? All right, so your range really is from that lowest point. I want to know what the y-coordinate of that lowest point is. Looks like it's -4, and then it keeps on going all the way up to negative infinity. And I'm assuming it's right at -4, even though in reality you can't tell that from a graph, okay? So that's the domain and range. That's what we've been talking about in several videos. All right, now for x-intercepts, well, that's where it crosses the x-axis. So you're looking for where does it cross the x-axis? And so I can see that it crosses here at the point 30 and over here at the point 70. Now, even though it's usually okay to just say the x-intercepts are 3 and 7, sometimes they specify that they want it written as an ordered pair. So I'm going to take time to do that, okay? And then the y-intercept, let me do that in a different color. The y-intercept is where it crosses the y-axis. So that's up here. And that, I counted that earlier, 1920, looks like it's at 21. And you wouldn't just say 21 unless it says that's okay. You would put the ordered pair 0, 21, okay? All right, now, the next couple of questions, next 3 actually deal with the increasing, decreasing constant thing. Now, these are going to be what we call open intervals upon which the function is going up, going down, or staying the same. Increasing is when it's going up as you look at it from left to right. So it's going to be rising as you look from left to right. Decreasing would be falling as you look at it from left to right. And then constant would be if it's the value of f is staying the same as you look from left to right. Okay? So I'm going to do those in 3 different colors. So let's take a look. All right, so let's do the increasing. We'll do that in red. Okay, so that happens. The graph seems to be going up from this point on. We'll talk about how to write it in just a minute. Okay, let me do the decreasing in blue. So the graph appears to be falling when you look at it from that spot to there. And then let me do the constant in green. And it seems to be constant over here, okay? All right, so for increasing, I'm going to do that in red. All right, what you do when you talk about the intervals on which f is decreasing, you're reporting the x values for which the function is going up. So we're really looking at the x values here and as it goes up. So that is right there at 5. So it's increasing from 5, and it keeps going on up all the way for any x value out here. The value of the function is going up. So that's from 5 to infinity. So this is an interval on x upon which the function is going up. And you report it as an open interval. You don't include that endpoint. Okay. Similar for decreasing. For decreasing, I'm going to do that in blue. Okay. And you see how it's going down? You want the x's of those 2 points. So this x is right here. This x is also 5. So it's decreasing from 0 to 5, and you report it as an open interval. Don't use brackets. Okay. And then for constant, I'm doing that in the green, and it's constant here. So from negative infinity until you hit the y-axis, which has an x-coordinate of 0, and it would be that open interval. Okay. Now, if they ask you about relative minimums or relative maximums, they're asking you where does the graph reach a high point, or where does it reach a low point? So this is asking us for a relative minimum. I'm trying to get some of this off of here. Get all this off. Okay. And so you see that lowest point right there. That's actually an absolute minimum on this one. And that happens when x is 5. So the number at which f has a relative minimum. So at 5, f reaches a minimum value of what appears to be -4. And so since it said the number at which f has a relative minimum, your answer would be 5. Okay, and then when it says, what is the relative minimum? Okay, so this right here is the answer to h. The answer to I is the -4. Okay, this is the answer to I. Okay, so what the minimum value is the y-coordinate. Where it happens is the x-coordinate. Okay. And then f of -1 is just using function notation in the concept of a graph. So that should mean that this is an x. You go over here to an x of -1, and in this case, you have to go up to hit the function. There's the point right there that has an x of -1 on this, and the y-coordinate appears to be 21. So your answer would be 21. Okay. All right, now k is function notation also, but do you see how they're really giving you the y value? They're saying f of x, or the y value. See, this is your x value when it's in the parentheses. So this one is saying the output of the function is -3. So your thought process should be completely different from the other one. Your thought process should be, okay, well, where do I reach -3? Down here. And it appears to happen in 2 spots. You might need to zoom in when you look at yours on my math lab. It appears to happen at 2 spots. This point looks like 4, -3. This ordered pair looks like 6, -3. So your answer would be at an x of 4 or an x of 6, and it's probably going to be a box where you just put those in with a comma. All right, now we're not really doing the even, odd, or neither. Even functions are symmetric about the y-axis, so matching on both sides. Odd functions are symmetric about the origin. And then a lot of functions are neither. This one's neither, okay? So things that are symmetric about the y-axis that you've encountered are things like that, okay, or the absolute value, or even the rational functions that look like that are symmetric about y. Things symmetric about the origin, cubic functions are, they kind of do like that. I should draw that better. Should match more nicely. Symmetric about the origin, it's like if I took this piece, flipped it, and flipped it again, you'd be down there. Okay, that's symmetric about the origin. And here's a rational function that's symmetric about the origin also. But we don't do much with that. I just thought I would tell you in the video. Okay, so this comes from the homework, increasing, decreasing, and constant. There's only 5 questions. This was the 4th one. So it gets at a lot of the basic function concepts, but it adds the part right here on increasing, decreasing, and constant that I wanted to mention.